Welcome back, engineers, to the Foundry by Forge College. I am so excited to have you here for this explainer because, well, we've finally reached the summit. Or, the final boss battle, depending on how your drafting is actually going right now. This is it, the absolute final step in drafting your master patent blueprint. Over the past few lessons, especially when we tackled evaluating risks and system trade-offs last time out, you've been doing the heavy lifting. You've analyzed the physics of distributed ledgers, you've scoped out the operational hazards. And now? Now our goal is to take all of those scattered blueprints and assemble them into a single cohesive, review-ready capstone proposal, your ultimate blockchain solution. So let's get right to work. All right, here is today's master plan. First up, the master assembly line. Then we lock down the problem and justification. Third, mapping the blueprint. Fourth, bulletproofing your blockchain. Fifth, charting out the implementation roadmap. And finally, number 6, the final polish. Let's forge these pieces together. Let's dive right into phase 1, the master assembly line. So remember, you are definitely not starting from scratch today. And hey, that is totally by design. You've already gathered all your raw materials from our previous sessions, things like your constraints tables and those risk assessments we just did. But putting them all together on the assembly line, that requires hitting a few core acceptance criteria. Basically, this is exactly what done looks like. You've got to clearly define the problem, polish up your architecture and wallet flow diagrams, finalize those risk matrices, chart a totally realistic roadmap, and ensure the whole package is ready for a tough review. And the glue holding this whole shebang together? Traceability. I can't stress this enough. If you make a technical claim, it literally must trace directly back to your earlier schematics. No exceptions.
Moving right along to phase 2, the problem and justification.
Okay, to justify your solution, you first need to clearly define the exact industry challenge you are solving. Just pull that directly from the constraints table you engineered back in lesson 2. But the absolute most crucial question your stakeholders are going to ask you is simply, why blockchain? You can't just sprinkle the word blockchain on a problem like it's, some sort of magic innovation fairy dust. That's not how engineering works. You have to really challenge yourself here to explicitly map at least 2 specific technical properties, stuff like tamper-evident logs or shared state across completely distrusting parties, directly to concrete, undeniable benefits for your specific use case.
Which brings us to phase 3, mapping the blueprint.
All right, with the problem officially justified, it is time to turn our attention to your visual schematics and give them a serious, heavy-duty engineering upgrade. A professional component architecture diagram explicitly shows your system boundaries. We're talking exactly what lives on-chain versus off-chain, the critical integration points, and which stores actually hold the authoritative state versus, which ones are just simple caches. A truly proper engineering diagram communicates data ownership and trust boundaries with crystal clarity. It shouldn't need an interpreter in the room to translate it. It absolutely has to speak for itself.
Next up, we break down your wallet flow into 3 absolutely critical steps. 1, actor interaction, 2, message signing, and 3, error and retry paths. You really must identify exactly who is signing which messages and precisely what data is being presented to the signer. And please listen to me very closely on step 3. Whatever you do, do not leave your users staring into the cold, dark digital void of a failed transaction without a retry button. A great engineer always designs for failure. Your flow must explicitly show those failure and retry paths for things like network timeouts or signing errors.
Okay, on to phase 4. Bulletproofing your blockchain.
Calling back directly to our previous trade-offs lesson, it is time to really secure the system against operational hazards. You've got to take an abstract, scary operational worry, like, say, a notoriously slow external API, and translate it into a concrete, totally actionable engineering task, a mitigation runbook. Basically, don't just sit there and say, well, the API might be slow. Say, we are going to add a queuing layer to decouple it, set strict alert thresholds, and establish a clear, tested rollback procedure. Literally every single high and medium risk has to have an operational owner and a verified mitigation plan attached to it.
Now for phase 5, the implementation roadmap.
Frankly, even the most brilliant, perfectly bulletproofed blueprint in the world requires a highly realistic rollout schedule if it's actually going to get built. So we require a mandatory 3-phase rollout: prototype, pilot, and evaluation. And I want you to really notice how highly specific and testable those success metrics have to be. We aren't just broadly saying, make it work. No way. We are explicitly saying latency under target with 95% successful transactions for the prototype phase. And for the pilot phase, uptime strictly greater than 99%. You have to prove definitively that every single milestone was met without a shadow of a doubt.
And that brings us to our final phase, number 6, the final polish. Before you even think about presenting this to your stakeholders, you need to run your blueprint through 3 crucial checkpoints, just to make absolutely sure it is structurally sound. First up, the artifact traceability test. Can you map every single claim you've made directly back to your evidence? Second, the diagram clarity walkthrough. Honestly, just grab a colleague, show them your diagram, and ask them to explain it right back to you. If they fail, well, your diagram needs revision, plain and simple. And third, risk to mitigation mapping, just to ensure every single high-priority risk has that verified runbook entry we were just talking about. 300. That is the strict, hard, maximum word count for the executive summary at the very beginning of your proposal document. 300 words. In that highly constrained space, you have got to punchily answer 3 core questions for whoever is reviewing it. What problem are you solving? Why in the world are you using blockchain to do it? And exactly what is the pilot ask and success gate? You've got to be concise, you've got to be crystal clear, and you need to hit those points with absolute surgical precision.
Because at the end of the day, traceability is everything. That right there is the absolute core thesis of this explainer and honestly, your entire Capstone project. An airtight proposal leaves absolutely no claim unsupported, period. It traces every single architectural decision and risk mitigation directly back to your earlier course artifacts. And let me tell you, when you actually do that, your proposal completely transforms from just being an interesting idea into an undeniable, totally review-ready engineering blueprint.
And just like that, that wraps up our Capstone Blueprint Assembly. Next up in the broader curriculum, we're going to dive headfirst into our Introduction to Cryptographic Hashes lesson. That's going to provide the critical background you'll need to really sharpen your data integrity arguments. But right before you head off, I want you to ask yourself this one final thing. Does your blueprint just describe some nice theoretical system, or does it mathematically prove it can survive the absolute chaos of the real world? Think about it. And while you're at it, I strongly encourage you to explore all the other incredible learning programs we offer. Head over to forge.college to really deepen those technical foundations. Keep building, keep refining, and I'll catch you in the next explainer.